Hello, welcome back to AP Psychology. I'm Miss Lee, and we are finishing up Unit 1 Scientific Foundations. This is the last set of notes, the last video in the unit. We are talking today about statistics. Some of the concepts that we're going to be discussing are kind of heavy. I don't want you to get intimidated. I don't want you to be scared. We're going to get through this together, and I'm going to do my very best to make this as simple as possible. We're only going to hone in on the skills that you need to do well in this class. If you have taken statistics before or are taking AP statistics, you will definitely have a little bit of a leg up, but we're going to go ahead and get started. If you don't have your notes, go ahead and grab them and let's get started. Okay, here are our learning targets today. These are the objectives that we'll be meeting today. We're going to talk about descriptive and inferential statistics, and we're going to be talking about some of the concepts that have to do with both of those, including measures of central tendency, variation, and frequency distributions. So let's go ahead and get to it. Okay, statistical reasoning. Why are we even talking about statistics in AP Psychology? Well, it's all about research. We have to have a way to show what we have discovered, to show what we have figured out with our research. And so we have statistical procedures that are going to help us analyze and interpret that data. It lets us see what if you're just looking at a bunch of numbers, if you're just looking at raw data, statistics helps us kind of understand what all of that means. On your screen now, statistical information about the state of Tennessee. You can see that our population is over 6 million people. Our median household income is over 52,000. Our poverty rate is about 15%, and the employment rate, not unemployment, but the employment rate is 57%, or a little bit over 57%. So this is important information to know, but if you don't understand some basic concepts about statistics, it may not really make a lot of sense of what these numbers mean. So one of the purposes of statistics is to describe our data, descriptive statistics. This gives us meaningful descriptions of data to show us what is most important. In the two charts below, you can see that the way we present our data can lead to incorrect conclusions. Both of these charts are showing the exact same information. On the left, it doesn't look like there's a lot of difference between the brands that are being shown here, the brands of truck. But if we kind of zoom in on it and change little ways that we are presenting the statistics, it really looks like brand Z sucks and our brand is really way better. But I want you to really pay attention to the y-axis, that vertical line. The numbers that we are showing are very different. So we want to be careful that we're not misrepresenting our statistics. So first, we want to talk about what some of those numbers mean. And a lot of this is going to be review for you, is my guess. Measures of central tendency. How do our numbers tend to go? That's what central tendency means. And we've got three measures of central tendency: mean, median, and mode. The mean is the arithmetic average of scores in a distribution. And what you do for that is you're getting an average. You are adding up all of the scores and then dividing by the number of scores. The median, and I literally think of this like a median in a highway. It's the middle. This is the middle score in a rank order distribution. And then mode, the most frequently occurring score in a distribution. You can actually have a multimodal distribution, but just for our purposes, the mode is the most frequently occurring. Measures of variation are ways that we talk about how the numbers deviate from the mean. This is kind of a big mouthful to say, but we can look at the range of numbers. This is the difference between the highest and the lowest scores in a distribution. So if you think about, let's say, for example, ages of family members, how far apart they are distributed. We may have a very large range of ages in a particular family. So you may have a newborn and you may have a 95-year-old. That would be a large range of numbers. The standard deviation is the average difference between each score and the mean. Now, I want you to kind of pull that word apart, standard deviation, the standard, the average. So basically how much a certain number is going to deviate or be different than the mean. Deviate just means different. It's the difference. So how much of a difference is between that number and the mean? And that's all standard deviation is. So in our graph here, you can see in red, there's a very small standard deviation. I can look at this without doing any figuring, any calculations, and just by looking at the range, I can tell that there is going to be a small standard deviation. The numbers really cluster around that mean. In the red, we do have a standard deviation of 10. So on average, our numbers are going to deviate from that mean by about 10. In the blue, we've got a larger standard deviation. You've got a wider range. They don't cluster around the mean as much. And so our standard deviation in blue is 50. So there's a much bigger standard deviation. For our purposes, for the purposes of AP Psychology, you're not going to be asked to calculate standard deviation, but you will need to apply what you know about this concept. So just by looking at numbers, you should be able to estimate which of the following sets of data have the greatest standard deviation. So in this first set of numbers, you've got 1, 5, 7, and 30. You've got a range between 1 and 30. The second set is 5, 10, 12, and 18. So you've got a range of 5 to 18. And then the last one, 30 to 35 is your range. Well, what we want to do is we want to look kind of at the difference between the numbers, the difference between 1 and 5, so 4, the difference between 5 and 7, 2, the difference between 7 and 30, that's a pretty big difference, so 23 is a large number. The next set, you've got a difference of 5, 2, 5. That last set of numbers has a very small range, so already you should suspect that it's going to have a small standard deviation, 2, 2, and 1. So which of the set has the greatest standard deviation? It's going to be that first set. So you can estimate the standard deviation by looking at the spread or the range of numbers. How far are they spread out? And you can find the mean and compare each of them to the mean. So you could figure that out through arithmetics, just calculating the mean and then looking at the standard deviation that way, but often you can just estimate it. Okay, normal distribution. This is a distribution of scores that produces a bell-shaped symmetrical curve. It's normal. In this normal curve, the mean, median, and mode fall at exactly the same point. Now, I don't want you to look at this graph to the right and get intimidated because I'm really only going to ask you to understand what's going on for half of this chart. So if 0 represents our mean, this is the standard deviation away from the mean. There's 0 difference between this point and the mean. It is the mean. Each of these spaces, each of these jumps is representing one standard deviation. That's what that little sign means, is a deviation. So 1 standard deviation, 2 standard deviations, and the numerical numbers represent the number of data that fall within 1 standard deviation, 2 standard deviations, and so on. So 34.1% of the data is going to fall between 1 and 0%. So that first standard deviation. An additional 13.6 is going to fall between 0 and 2 standard deviations. So you would add these two together. 2.1% is going to fall between 2 standard deviations and 3. So if you want to know how much fall in 3 standard deviations, you're going to add these 3 numbers. And then from 3 and on is going to be 0.1%. So not very much at all. Now I said I want you to only memorize half of the numbers. The last number that I want you to remember is 50. 50% of all of our scores is represented here. And so if you are being asked about the entire population, you see that it's a mirror image, it's a mirror reflection. All of these numbers are exactly the same. So you really only have to memorize half of this chart. And it is important because you may get asked to look at a chart like this and kind of tabulate how many fall within 2 standard deviations. Well, you would add 34.1 and 13.6 for a total of 47.7% of all of these numbers are going to fall within 2 standard deviations from the mean. Okay, a skewed distribution. All it means is that there are some outliers, data points that lie at one extreme or one end of the curve. So if you're thinking about scores on a test, normal distribution is going to look a little bit like this, but a skewed distribution, imagine if one of the students gets a score of 150%. That is going to skew our data. If we try to only get an average, that's going to throw our data way off because of this outlier. It skews our data, so it changes it. It makes it look muddled. Whether the skew is positive or negative is determined by where the outlier is. So in a negatively skewed distribution, the number is going to be a little bit lower. So I usually just kind of try to remember that a lower number is negative. And so if you have a lower number, let's say someone got a 1% on that same test, it's going to pull the numbers in that direction. It's going to negatively skew your distribution. The example that I gave earlier about 150 percentage points on that test, it's going to be a positively skewed distribution. The outlier is going to be in a much higher area on your chart, so it's going to pull all of the numbers towards that more positive end. And so if you think about what that's going to do to our mean, median, and mode, what is it going to do to our central tendency? Well, it's going to impact those numbers. The outliers are going to impact. Hopefully you see that the measure of central tendency most impacted by the outlier is going to be the mean. The mode is least affected and the mean is most affected. So it's going to pull the mean towards the outlier. You can see that over here as well in the positive skew. Okay, so that is all about descriptive statistics. You're describing what you see. Inferential statistics allows us to estimate what's happening based on our sample population towards the general population. So looking at our sample, what can we infer is going to happen to the larger population? And this is all based in probability theory. So you don't really have to worry about how this is all tabulated, just understand the general context. So basically inferential statistics allows us to say if it worked for this small group of people, we can estimate it's going to work for the rest of the population. And if you have set up your experiment right, if you have done your due diligence in making sure that you've got a random sample and that you have set up your groups randomly, then you could say, for example, in a drug test, if the meds work for this sample, we can estimate that they'll have the same effects on the rest of the population. You're inferring. There's always a chance for error in whatever the findings could be, so the hypothesis and the results have to be tested for significance. That is a big, important word in statistics. Again, if you've taken statistics before, you understand that significance means something very specific in statistics. Okay, so we test it out by using a null hypothesis. Basically what the null hypothesis is that as you're going into your research, your null hypothesis states there's no difference between the two sets of data, your experimental group and your control group. You're stating that there is no difference. So basically, it's the opposite of the hypothesis. And what you're doing is you're saying that until the research shows or proves or without any kind of a doubt that you have proven your hypothesis, you have to assume that the difference is due to chance. So you are, as the researcher, the responsibility is on you to prove that your hypothesis is correct. So here's what it looks like. A null hypothesis. I'm going to ask you to just kind of pause this slide and just take it in because there's a lot going on this slide and I want you to understand as I'm talking about this information what I'm talking about. So to the left on this end is what the decision the researcher makes. So this is whether or not the researcher rejects the null or accepts the null. So when you reject the null, you are accepting that your hypothesis is true. The truth about the population is over here. The null is true and the null is false. You've either got correct decisions being made or you have a type 1 or type 2 error being made. In a type 1 error, you reject the null but the null is actually true. In a type 2 error, you accept the null, but the original hypothesis is actually correct. So it's really easy to get this all mixed up until you see it working in the real world. So let's take a real world example. Okay, so let's say you go into the emergency room and you have some pain in your side. It's very intense, excruciating pain. The hypothesis could be that the patient exhibits signs or symptoms of appendicitis. Therefore, the appendix needs to be surgically removed. That's the hypothesis of the doctor. The null hypothesis would be that the appendicitis is not the reason for the symptoms. There's something else going on, so the appendix does not need to be removed. So that's the original hypothesis and the null hypothesis. You can see that the null is the opposite of your original hypothesis. If the doctor rejects the null and they accept the original, but the null is true, this is a type 1 error. So basically, if the doctor says it's absolutely appendicitis, I don't need to run any tests, they might remove the appendix and have an unnecessary surgery. Maybe it was a stomach flu or a stomach virus and the person was not having appendicitis at all. This could result in malpractice. That's bad. So let's say that the doctor accepts the null, and in the same case, the null is true. So the person had some kind of a stomach bug or some other thing happening. Maybe they were exercising and they got a little stitch in their side. When they accept the null and the null is true, that's the correct decision. The unnecessary surgery is avoided and the doctor will continue to investigate other potential causes. So let's say that the doctor rejects the null and the null is false. So they go with their original gut. They go ahead and say, yes, it's the appendix. This person is having appendicitis and their appendix is going to explode if we don't do surgery. The appendix is removed and the patient fully recovers. This is a correct decision. However, if a type 2 error is made, the doctor is going to accept the null, the opposite of what the symptoms are showing, but the null is false. So they really do have appendicitis, the doctor does not do surgery, and the appendix explodes. The person could actually risk death, and that is really bad. So type 1 and type 2 errors are really made in real life, so they're very important to make sure that we have the truth about the population before we decide whether to accept or reject the null hypothesis. Statistical significance. So I want you to take a deep breath. This is important. This is super important to understand. Statistical significance means that the differences observed between our two sample groups, the experimental group and the control group, is probably not due to chance. So if you think back to our last video when we had an experiment to decide if caffeine helps teachers feel more alert and happy. The difference, hopefully, if there is statistical significance, is due to a real difference between the group or the independent variable. This means that the caffeine really did have an effect. It really did impact the mood and the alertness of the teachers. Data is said to be significant with the likelihood of a difference being due to chance is less than 5 times out of 100. So only 5% of the time. In other words, there's a 95% chance or greater that the difference is because of your independent variable, that caffeine. So shown numerically, it is shown as a p-value. P, you could almost just kind of in your mind say chance. So the chance of this happening due to chance is less than or equal to 0.05 or 5%. And it's important to understand statistical significance because if research is statistically significant, it means that the results are probably not due to a fluke or just by chance, because sometimes things happen and it could just be a coincidence that all of the teachers looked a certain way even though the caffeine really did or did not impact them. All right, that's it for statistics. That concludes Unit 1, Scientific Foundations in Psychology, and I will see you in our next unit, Biological Bases of Behavior. I can't wait to see you then. Bye for now.